Praise be, we made it to topic 11, y'all. This is a section and a half, huh? So for topic 11, we're going to practice graphing polar equations and we're going to do kind of like the point plotting method, okay? So we're going to like find very specific points, we're going to plot them, we're going to kind of maybe consider some symmetry, okay? So for example 12, and we do have two of these, but for example 12, it says use the following polar equation to answer the questions below. We have r equals 2 plus 2 cosine theta. So this very much looks like r equals a plus a cosine theta, which really looks like r equals a times 1 plus cosine theta, which is just absolutely begging us to say it's a cardioid. Okay, and that's actually the first question we have here. Based on this equation, the graph will be a cardioid. Okay, so we have that. Now we also have a situation where we're dealing with cosine. Okay, so when you're dealing with cosine, this is not always necessarily the case, but in this graph, it is going to be the case. We're definitely going to be dealing with some symmetry about the x-axis, or when you're in this polar coordinate system, we would call it the polar axis. So we can kind of keep that in mind. We're going to have some symmetry about this polar axis right here, okay? Now it says find polar coordinates where theta equals 0, pi over 3, and pi. So we're going to just do like old school point plotting. You could even create a table if you wanted to. I'm just going to kind of list these out, but you could create like, you know how when you first learn to graph equations, you do like your XY table of values? You could absolutely do that. You would just do R theta, okay? So let's go ahead and figure what these are. So we're going to take this equation, R equals 2 plus 2 times cosine theta, and we're going to plug in these three values for theta one at a time and see what we get for R. So R equals 2 plus 2 times cosine of 0. Well, what is cosine of 0? So if you can envision like a little unit circle, okay? So if you go out 0, or if you open up 0 degrees, you're going to have a point on your unit circle like 1, 0. And we know that cosine is the x coordinate. So we would say cosine of 0 is just 1. So we would get over here 2 plus 2 times 1, which is 2 plus 2, or 4. So we get the polar coordinate. Remember, polar coordinates here. R is 4, and we set our theta as 0. Okay? Now we're going to repeat this process, but this time we're going to use pi over 3. So r equals 2 plus 2 times cosine of pi over 3, which is 2 plus 2 times. Well, if we had pi over 3, that's kind of like up here. And if we were on the unit circle, we would have the ordered pair 1/2 comma root 3 over 2. So cosine of pi over 3 is a half, okay? So we get 2 plus 2 times a half. Well, 2 times a half is just 1. So we get 2 plus 1, or 3. So we have the polar coordinate 3 comma pi over 3. And then finally, we were told to figure out what r is when theta is pi. So r is 2 plus 2 times cosine of pi. Well, if we're on that same unit circle and we go out pi radians, we would have some point -1, 0. Okay, so cosine of pi radians is -1. So we get 2 plus 2 times -1. Well, 2 times -1 is -2. So we get 2 minus 2, or 0. So we get 0 comma pi. Okay, so those are 3 points that we have on this graph. And we already kind of know from our investigation, we'll say, of cardioids, it feels like 1,000 videos ago, that when you're dealing with a cardioid like this, where we're talking about cosine, we're expecting some kind of symmetry about the polar axis. So keep that in mind as we kind of plot these points, okay? So let's see, we have the polar coordinate 4, 0. So we are opening up 0, I was about to say 0 degrees, 0 radians, and we want to go out 4 units along that terminal side. So we will go out 1, 2, 3, 4. So we have that point on this cardioid. Okay. Next, we have the angle pi over 3. So this is pi over 3 right here. So if we opened up pi over 3 radians, we would want to go out 3 units along the polar or along the terminal side from the pole. So from the pole, we would go out 1, 2, 3. Okay? Let me get rid of my side work here so we don't get lost. Okay, and then finally we want to go out pi radians, and r is 0, so we really just stay at the pole, okay? Now, that's not exactly a whole graph, right? We're not trying to graph some wacky triangle, but we know that the shape is a cardioid, okay? And we know that in this case, because we're dealing with cosine, we should expect symmetry about the polar axis. So let's find negative pi over 3. Okay, if we had negative pi over 3, because we know that we would have symmetry about the polar axis, we can kind of mimic pi over 3, where we go out 3 units along the terminal side. Well, we can go out 3 units along the terminal side of negative pi over 3 as well, okay? And then we can kind of just sort of fill in, we're going to sketch the rest of the graph. So we go out like this, into the pole and back out. It's maybe not the best picture I've ever drawn. Okay, it's getting worse. It's like the harder I try to fix it, the worse it gets, or the worse it gets. So, goodness. That's as good as it's gonna get. It's late. I don't think I could do it any better. Okay, so there we have our cardioid. Now, one of the questions here says list the intercepts. I only put this here just so you could understand that, like, when we're in the rectangular world, we have x and y intercepts. So when you're looking for an x-intercept, you replace y with 0, and then you solve for x. If you're looking for a y-intercept, you replace x with 0 and you solve for y. Same thing kind of works here. You could do that with r and theta. So if you're looking for like an r-intercept, let theta equal 0 and figure out what r is. If you're looking for, let's call it your theta-intercept, that's not really it, but you let r equals 0 and figure out what theta is. Okay, so you can just do the same thing. So you replace 1 with 0. So basically our intercepts are 4, 0, and 0, pi. Those would end up being our intercepts here, okay? And then finally, describe the symmetry. This is horribly, horribly drawn, okay? But if this were prettier, I'm going to give it one more go. If this were prettier, I'm going to turn my tablet sideways and see if I can do better. If this were prettier, we would have symmetry with respect to the polar axis, or you could say, okay, that's not terrible. All right, so we can say we have symmetry with respect to the polar axis, or you could say the x-axis. Okay, technically, if you're in the polar coordinate system, you would say symmetry with respect to the polar axis. Okay, so there you have it. That's our first graph that we did by hand. If you want to double check it, you are welcome to go pull out your calculator and double check it, but I feel confident about it. All righty. Last up, let's look at example. I cannot believe it. Example 13 is here, y'all. So we have example 13. It says use the following polar equation to answer the questions below. We have r equals 2 minus cosine theta. We want to know what kind of graph we're going to get. We're going to look at some different points here, and then we're going to discuss symmetry. Okay? So in this case, this is looking very similar to like r equals 2 minus, let's go ahead and throw a 1 in there, times cosine of theta. So we have these two different values. We have one value plus or minus the other value times cosine of theta. So let's say this is looking like r equals a minus b times cosine of theta. And if you remember, that's a limacon or a limacon, okay? So we do have the situation where A is greater than B. So this is definitely, like I said, a limacon. And it's one without an inner loop. Because A is greater than B, we don't have that inner loop, okay? So again, let me write it here where I was supposed to. Limacon without inner loop. Okay, now we're going to do the same thing. We're going to do that whole like point plotting, but I do want to show you how you can use your calculator to kind of like speed this up so you don't have to like plug all the points in. So in the previous example, I showed you, hey, if we choose values for theta, you literally plug them into the equation and you simplify and figure out what R is. Let's use our calculator to kind of speed this up, okay? So we're going to use the calculator just for the simple fact that we can get these points really easy, okay? So we're going to figure out what R is when theta equals 0, pi over 2, pi, 3 pi over 2, and then we'll try 2 pi as well, even though 0 and 2 pi are going to be the same thing. Okay, so let's go to the calculator. We are going to be cheater pumpkin eaters, but nobody has to know, man. All right, where is my calculator? Is that it? I've changed screens. Yeah. Okay, so let's go to y equals. Let's clear out all the old stuff. And we want to type in 2 minus 1. We don't really have to put the 1, but it's 2 minus 1 times cosine theta. So 2 minus cosine theta. We can go to the graph, okay? Now, this one, it's a little bit hard to see, okay? It's kind of flat right here at x equals positive 1. It is a little flat, so this is not like a perfect circle. It's barely kind of concave in there, okay? So don't think this is a circle. It's not. It's this weird, like barely flat side. That's what makes it a limison. Okay, now what we're going to do is we're going to make sure that we have the polar grid on. So we're going to go second zoom, and we do. We've got our polar grid. And then we're going to go back to the graph and we're going to go second trace. What this does, we're going to choose value. What this does is it allows us to plug in values for theta and it'll tell us what R is, okay? As long as you have that polar grid on, okay? So we wanted to test for theta values of 0. So when theta is 0, we get R of 1. So you want to write down the polar coordinate 1, comma 0. And I'll put these on the worksheet in just a minute. I don't want to keep flipping back and forth. All right, we're going to go back and try for pi. You can just start typing pi, and it'll automatically go back to that screen. So we want to do pi over 2. So when theta is pi over 2, we get that R is exactly 2. Let's try for just pi. So second caret, and then we've got theta down here equaling pi, hit enter. And we get for this one, we get R is 3. Then we want to do 3 pi over 2. So we're going to go 3 second caret divided by 2 and hit enter. And you can see it moves a little cursor to exactly theta is 3 pi over 2. And for this case, R is 2. And then we want to check 2 pi. We expect it's going to be the same thing as 0, but let's check it just to be safe. So we get 2 pi. And, oh, I think I know what the issue is. I think it's my window. What did I do there, y'all? Did I type something in wrong? So we're going to go second trace. We're going to choose option 1, and we're going to type in 2 pi. And if this doesn't fix it, it might be my window. We know that 2 pi is going to give us, it'll give us 1. Okay, I'll play around and figure out why it won't let me type it in. Okay, and if you all know, let me know. And it could be that my window is not set correctly. Okay, it could be because it's rounding this. So let's say we go 3 pi. Let's see if that fixes it. That fixed it. All right, so we get our R is officially 1. Okay, so let's go back to the worksheet. I'm going to fill in these values, then we'll sketch our graph. Okay, so we checked when theta was 0, and we got that R was 1. We checked when theta was pi over 2, and we got R is 2. So 2 pi over 2. We have 3 comma pi. We have 2 comma 3 pi over 2. And then we finally, it took me forever, but we've got 1 comma 2 pi. Okay, so let's see. At 0 radians, we go out 1. At pi over 2 radians, we go up 2. At pi radians, we go 3. So 1, 2, 3. At 3 pi over 2 radians, we go 2. And then 2 pi, we're back at 1. So remember, it was barely concave right here. It was almost flat for us, but that's okay. There we have it. Okay. So you can do the point plotting method. It's like when I look at it really close, they look good. And then I step back and I look at the bigger computer screen in front of me and it's just pitiful, but you know what it's supposed to look like. Okay. So you can use your calculator to help you with this like idea of point plotting. Don't be ashamed to use it. I'm fine with you using it. There's no sense like, doing all the work by hand if you don't necessarily have to. If we were to describe the symmetry, we could say that this is symmetric with respect to the polar axis or to the x-axis. Okay. But there you have it. That is graphing using point plotting, using the calculator, graphing where we convert things to rectangular because we kind of understand how rectangular stuff works. So we've done a ton, an absolute ton in this worksheet. So be super proud of yourself. You made it to the end. I made it to the end. I only had half a glass, well, two-thirds of a glass of Diet Coke. We're rocking and rolling, y'all. All right. So that's it for 10.2. Next up, we will do 10.3, which if memory serves me, it's the complex plane or something like that. All right, so complex numbers, complex plane, something to that effect. All right.